Mastering Python type hints for clean code. In this video, we'll learn how to apply Python type hints for cleaner, more maintainable code. Gain skills to reduce bugs and enhance code readability in your projects.
Welcome to our journey into Python type hints. Did you know that adding just a few characters to your code can significantly enhance its readability and maintainability? Type hints in Python serve as a powerful tool for developers to specify the expected data types of variables, functions, and methods. This small addition can lead to fewer bugs and more understandable code, paving the way for easier collaboration and maintenance. As Python continues to grow in popularity, especially for large-scale projects, understanding and implementing type hints has become a crucial skill. Throughout this video, we'll explore how to effectively use type hints to write cleaner and more efficient Python code. Why should you care about Python type hints? Well, they offer several key benefits. First, they significantly enhance code readability, making it easier for others and future you to understand what's happening in the code. By clearly specifying the intended types, type hints help in reducing bugs that might arise from incorrect data types being used. This, in turn, facilitates easier code maintenance. When working in teams, type hints can improve collaboration, as everyone can quickly grasp the expected data types. Moreover, type hints enable better tooling support, allowing IDEs and linters to provide more accurate suggestions and error checking. As we dive deeper, you'll see how these benefits can transform your coding experience.
Let's break down the syntax and basic usage of Python type hints. At its core, type hinting involves annotating variables and functions with the expected data types. For example, if you have a variable intended to store integers, you can annotate it as follows: x, int. When it comes to functions, you can annotate both parameters and return types. Here's a quick example: def add a, int, b, int, greater than int. This function takes two integers and returns an integer. We'll also explore the typing module, which provides additional support for more complex types. Understanding these basic concepts will set the foundation for applying type hints effectively in your projects.
Now, let's delve into using type hints with lists and dictionaries, two of the most common data structures in Python. For lists, you can specify the type of elements it contains using the list type from the typing module. For example, list int indicates a list of integers. Similarly, for dictionaries, you can use dict to specify key value pairs, such as dict_str, int, which represents a dictionary with string keys and integer values. We'll also cover nested type hinting, where you can have lists of dictionaries or dictionaries of lists. Be mindful of common mistakes, like forgetting to import the necessary modules, which can lead to errors in your code. Type hinting is particularly useful for functions and methods, as it clearly communicates the expected input and output types. For function parameters, you can add type hints directly in the function signature. Similarly, you can annotate the return type using the >greater than symbol. When dealing with methods within classes, the process remains largely the same, but with considerations for self and CLS parameters. Handling optional parameters can be done using the optional type from the typing module. Throughout this section, we'll share best practices for applying type hints to functions, ensuring your code remains clean and understandable.
When coding generically in Python, typevar becomes an invaluable tool. Typevar allows you to define your own types that can be used for type hinting in functions and classes. This is particularly useful for creating generic functions that can handle various data types without sacrificing type safety. For instance, you can create a generic function to find the maximum of two elements, regardless of their type. Typevar can also be constrained to specific types, offering flexibility and control. We'll go through several examples to illustrate how typevar can be used to enhance your generic programming practices. While type hints bring numerous benefits, they also come with potential pitfalls. A common mistake is overcomplicating annotations, which can lead to confusion rather than clarity. It's crucial to understand the limitations of type hints. They are not enforced at runtime, and it's possible to misuse them. When working with legacy code, introducing type hints requires careful planning to avoid breaking existing functionality. Additionally, ensure compatibility with the Python version you are using, as type hinting features have evolved over time. We'll discuss best practices to maintain consistency and avoid common pitfalls, ensuring your type hints enhance rather than hinder your code. To take type hints to the next level, integrating MyPy static type checker for Python can significantly enhance your code quality. MyPy analyzes your code, checking the type hints for any inconsistencies or potential errors. Setting up MyPy in your project is straightforward, and once configured, you can run it to receive detailed feedback on your type hints. Understanding the MyPy output is key to identifying areas of improvement in your code. By regularly running MyPy, you can catch type-related issues early in the development process, leading to cleaner and more reliable code.
As we wrap up, Let's recap the journey we've taken through Python type hints. From enhancing code readability to reducing bugs, type hints offer numerous benefits that can transform your coding practices. We encourage you to start implementing type hints in your projects and experience the improvements firsthand. If you're hungry for more Python knowledge, be sure to explore additional resources and tutorials. We'd love to hear your thoughts and experiences with type hints. Leave a comment below. Don't forget to subscribe to our channel for more insightful Python content. Thank you for watching, and happy coding!